Imagine a humanoid robot that you don't program for every move. You teach it. You say, pick up that part, place it here, then sort the rest by type. It tries, it fails, it adjusts, it gets better. And here's the wild part. Boston Dynamics CEO says Atlas needs to learn a new task in about 24 to 48 hours before it's ready for real factory deployment. That's not a demo goal, that's a product goal. So today I'll show you how robots self-learn, what's actually new about Gemini robotics, and why this DeepMind plus Boston Dynamics move could be the moment robots stop being stunts and start being useful. Because this isn't a robot video. This is the beginning of trainable robots. Robots that learn tasks like software updates. Boston Dynamics and Google DeepMind announced a partnership at CES 2026 to integrate Gemini Robotics AI foundation models with Boston Dynamics' new Atlas robots. In plain language, Atlas is getting a smarter brain that can better understand scenes, follow instructions, and improve task performance faster. And according to reporting on the CES reveal, a product version aimed at helping assemble cars is already in production and planned for deployment by 2028 at Hyundai's EV manufacturing facility near Savannah, Georgia. So this isn't just research, it's aiming at a real factory timeline. Now the real question is the one viewers actually care about. How does a robot self-learn? When people hear self-learning robot, they imagine magic, but robots learn through a loop. Here's the clean version. Observe. The robot sees the world through cameras and sensors, where objects are, what's blocking them, what looks graspable, what looks fragile. Attempt an action. It tries. Reach, grip, lift, rotate, place, step, whatever the task requires. Get physical feedback. This is the difference between a robot and a chatbot. Robots get reality feedback. Did it grip too weak and the object slipped? Too strong and it crushed something? Did it hit the table? Did it miss the bin? Did it complete the goal? Update the policy. Policy just means the robot's decision system for what to do next, given what it sees. It adjusts to increase success and reduce failure. Repeat, at scale, often first in simulation, fast plus safe, then in real-world trials, accurate plus messy. That's self-learning. Try, feedback, adjust, repeat. One concrete example, so it feels real. A robot tries to pick up a metal part. It slips. The sensors detect slip and force mismatch. Next attempt, it changes grip angle, increases force slightly, slows the lift, stabilizes the wrist. Same task, better execution, no human rewriting code. That's the self-learning loop. Now here's why Gemini robotics matters in that loop. What? Foundation model brains change. Traditional robotics has a painful limitation. Even if the robot's body is amazing, you still need endless engineering to handle. New objects, new layouts, new lighting, new edge cases. Foundation models change the direction because they try to combine three abilities: vision, understand the scene; language, understand the instruction; action, turn decisions into movement. And Wired described this partnership goal as giving robots contextual awareness and better object manipulation skills so they can work in more dynamic environments, starting with Hyundai's auto factories. So the promise isn't Atlas can dance. The promise is Atlas can learn useful tasks faster. That's why this moment is getting so much attention. It's the same general intelligence engine idea that powered chatbots, now aimed at the physical world. But the honest question is, robots have had promises before. Why might this actually be different? Why this feels like a real physical AI moment? 3 reasons this wave has momentum. Language becomes the interface. Humans don't want to code robots. They want to tell them what to do. And learn tasks within 24 to 48 hours is exactly the kind of metric you'd only say if you're chasing real operational workflows. The target is industrial first. This isn't home robots tomorrow. It's robots doing boring, repeatable work in controlled spaces. That's where value is highest and safety is manageable. The deployment timeline is being publicly stated. The CES reporting explicitly ties Atlas to a product version aimed at car assembly and deployment by 2028 in Hyundai's factory context. So we're moving from cool clip to planned rollout. Now we need the part most channels avoid, because it's the difference between hype and truth, the demo trap, and how you can spot it instantly. A robot demo is not a robot product. A demo is perfect lighting, staged objects, controlled environment, unlimited retries, careful editing. A product is unpredictable conditions, random human interference, varied objects, zero tolerance for unsafe behavior. So if we want to be real about this, we need to confront the 3 robot killers, because these are what stop robots from scaling. Killer number 1, dexterity. Hands are brutal. Picking up a box is easy. Picking up a crumpled shirt, plugging in cables, handling slippery parts, grabbing thin objects from a messy pile, that's where robots fail. Dexterity needs tactile sensing, precise force control, micro adjustments in real time. A foundation brain can help plan actions and interpret scenes, but hands still require better sensing and training. Killer number 2, generalization. Generalization means, does it still work when the world changes? Different room, different part shape, different surface friction, different lighting, different object placement. This is why the brain matters. A more general model should, in theory, handle variation better than brittle rules. Killer Sarger 3, Safety and Reliability. In physical environments, mostly correct is not enough. Robots need predictable motion, safe failure modes, uncertainty awareness. I'm not sure, slow down, ask for help. And safety is explicitly part of the concern and coverage of smarter robots, because more capable physical agents create higher stakes. So the real scoreboard is dexterity, generalization, safety. If this partnership is the beginning of the real thing, progress must show up here. But there's another hidden bottleneck that decides everything. The real bottleneck. Robots need action data. Chatbots had a cheat code. The internet is full of text. Robots need a different kind of data. Video plus action, positions plus forces, success, failure signals, recovery behavior when something goes wrong. That's expensive, that's hard. So physical AI doesn't just require a smarter model. It requires a learning pipeline that can generate and refine action data at scale. Simulation training, teleoperation, humans guiding the robot, imitation learning, reinforcement learning. And we're seeing this emphasized in real reporting. For example, CBS described Atlas learning using supervised approaches via teleoperation, generating training data that later supports autonomous performance. This is where robots learn like software becomes real. You can't ship task updates fast without a pipeline that creates action data fast. Now let's talk about the curve that makes this story explode. Why 2026, 2028 could be the shift from demos to deployments. This isn't guaranteed, but it's why serious people are watching this. When robots start deploying in real facilities, they generate real experience. That experience becomes training data. That training data improves the model. And then updates ship back into the robots. That loop compounds. And the partnership is explicitly aimed at giving Atlas the intelligence to operate in industrial environments at scale, not just in labs. So the real story isn't one robot learned one task. The real story is the learning loop might finally have the runway to compound. Now, numbers. Because numbers make the viewer feel that this is real. The money segment, the cost curve is the plot twist. Robots are not hypothetical. They have price tags. Spot, real commercial robot pricing. Spot was sold commercially with a reported Explorer Kit price of $74,500. Digit, enterprise humanoid pricing. Agility Robotics CTO said Digit sold for $250,000, expecting the price to drop with volume. Unitree, the price shock. Reuters reported Unitree's humanoid R1 was priced at $39,900 yuan, about $5,566, a massive drop from its earlier model pricing. This is the curve. At $250K, humanoids are enterprise experiments. At $75K, specialized robots become ROI tools. At $5 or $6K, the market pressure becomes mass adoption if capability keeps rising. And this is why the brain matters so much. As bodies get cheaper, intelligence becomes the differentiator. Now let's get practical. Where will robots actually win first? Where robots will actually win first. If you want credibility, you don't say robots will do everything. You say robots will win here first. Warehouses, structured spaces, repeatable tasks, predictable paths, sorting, moving bins, handling parts. Massive ROI if reliability is high. Simple factory tasks, not artisan work, not chaotic environments. Standardized parts, standardized flows. This matches the public framing around Atlas being aimed at factory work in Hyundai's context. Controlled facilities, labs, regulated environments, places with strict safety rules and robot-friendly layouts. Homes come later, because homes are chaos, and the 3 robot killers are strongest there. So is this top tier real, or another hype cycle? Here's the honest answer. This partnership is a breakthrough in direction, not a completed revolution. It signals the shift from robots as program tools to robots as trainable platforms. The question is whether the learning pipeline compounds. And that's why the CEO's 24-48 hours to learn a new task target matters so much. It's basically a declaration that they're aiming for rapid, repeatable skill updates, like software. If they can hit that in real environments, the demo era ends. What happens next? Here's what to watch for. In order, instruction following improves in real spaces. Robots taking natural language tasks and executing them reliably in controlled environments. Manipulation reliability increases. Less dropping, better recovery, safer movement around humans. Deployments that look boring but matter. Part sequencing, sorting moving objects, repetitive logistics tasks. Skill updates start arriving faster. The real software moment is when task updates accelerate because data pipelines accelerate. And once that happens, you don't just build a robot, you build a platform. The takeaway. DeepMind A+. Boston Dynamics is not just a headline. It's a signal that foundation model intelligence is moving into physical systems, starting with Atlas for industrial work. And the big promise is simple. Robots won't be programmed task by task forever. They'll be trained. They'll improve through experience. They'll get skill updates like software. Now I want your take. Do humanoid robots win because they fit a world built for humans? Or do specialized robots win because they're cheaper and more efficient? Comment humanoid or specialized. If you want part 2, I'll break down the hidden battle that decides everything. Robot data, who can scale action data fastest, and why that matters more than the robot's body. Type part 2 if you want it.